Wow, welcome to measurement part 2. This is talking about perimeters. And what's that? I think we've got the answer right here. We want to ask the question, how far is it around the outside excuse me, of a figure or of a construction here? If we wanted to fence this particular park, how many meters would we need of fencing material? And if we wanted to frame this window, maybe this is a stained glass window, how would you work out what length of framing you needed and how you would do it? So measurement involves quite a few interesting applications. So let's go and ask the question, how far is it around the outside of something? And here's some screen clippings from Hayes and Harris publications, and their section B here from their textbook, which you should grab a copy of, is on perimeter. And in English, the word perimeter, if you like, refers to the boundary of a region, the length of the boundary, or how far is it around the outside. So here's our formal definition coming from their textbook. The perimeter of a closed figure is a measurement of the distance around the boundary of the figure, and how far it is around the outside. Okay, let's do some work on this stuff. Hopefully you've seen some of this before. It's a fairly simple idea. Find the perimeter of these polygons. Now, a polygon is a plain, flat figure which's got straight sides, and poly means it can have many sides. The simplest polygon would be a triangle with 3 sides. The next simplest would be a quadrilateral with 4 sides, and so on. Okay, so here we have a rectangle, and let's see if we can find the perimeter. And we've got units marked off here, so you can see it's 6 units long, 3 units wide, and go around again along here. How far is it around the outside? So adding them all up, so 18 units. The units of measurement might be what? Meters, a basic one. This could be kilometres if that's a really big rectangle out in the country somewhere where it's a paddock. Or it could be centimetres, couldn't it? Remember all those units from the last presentation. All right, what about this triangle? What's the distance around the boundary, or how far around the outside? Let's go around there. We're going to add them up. 9 plus 10 plus 12. 31 centimetres. You get the idea. Fairly straightforward. And here, this is a bit of a little tricky one here. We might start at 11. On this 11 side, go to there, so it's 11. But hang on, these mean they're all equal. So we've actually got 3 lots of 6 centimetres. So that's a little quick trick you can do, rather than just list them all out. So that's 11 plus 18 is 29 centimetres. Do you get the hang of it? All you're doing is adding up all the distances, but make it around the outside of the particular shape. Excuse me, got a bit of a cold here. Okay, some shapes, of course, have certain properties that will make it easier for us to work out. So a square has 4 equal sides. So it will just be 4 times s, the side length. And so does a rhombus. A rhombus is sort of a square pushed out of shape, or a parallelogram. Okay, it's got parallel sides. Those 2 are parallel, and these 2 are parallel. So parallel and equal sides. So again, it's just 4 times the length of one side, because in those 2 little diagrams, all the sides are equal in length. So the perimeter is 4s. Have a look at that. Okay, let's have a look at some other ones where you can do a bit of a shortcut to find the distance around the outside. A rectangle has 2 sides equal there and 2 sides here. So it will be 2 lots of B and 2 lots of A. Okay, or A plus B plus A plus B. 2 lots of A plus B, if you like. And here's another one, a parallelogram. This is a quadrilateral with opposite sides parallel. If those opposite sides are both parallel, then they'll be equal in length. That's a property of a parallelogram. And similarly here and here, notice these have single dashes, so they're not equal to the longer side, but there's 2 of them as well. So again, it's 2A plus 2B, or 2 lots of A plus B. And a kite A kite is just as the word sounds. It's a shape you'd make if you were trying to fly a kite. And these two pieces are equal, so there's symmetry about that diagonal there, and these two pieces are equal. So you've got an A plus a B, and then double it. So there are some little tricky do's you can do rather than just simply add up all the various pieces. See if you can spot some similarities there. Okay, let's go and do some now, and I want you to try and use the ideas we've just talked about to find the perimeter of these figures. Okay, so you could use the tricky idea of 2A and 2B if that works in the particular shape. Otherwise, you're just going to have to add them up. All right, let's have a look at the next one. You need a textbook for the next one because you're actually going to measure the lengths on a ruler. So you won't be able to do that on screen because the screen is bigger than the diagrams in the book. Okay, you could do it on screen, but the answers I've screen clipped are actually from the textbook, and these figures are bigger, putting them on screen. Okay, so pause the presentation and have a go. You go down to question 3. You can do question 3 without a ruler because we've got the lengths labelled there, so you can just find the length around the outside of the figure by adding them all up. Okay, watching out for ones that are equal to each other. Look for these little symbols here. All right, we'll keep going, and you might toggle forward in a minute and check that you're getting them right. So here's the first 3 questions. Try not to do a whole lot and find they're wrong. Check as you go. All right, let's go down and see some slightly different variations now. So here's another example from Hayes and Harris. Find the perimeters of the following figures. So this is a square. It's got equal sides. So we can just say it's 4 times the side length, 4 times 8, 32 centimetres, rather than going 8 plus 8 plus 8. And here, of course, we've got a rectangle. We know these two are equal, and going by those symbols, those two are equal. So we could just add up one lot of A and B, 7 plus 5, and double it. So you'll have 24 metres there. So some tricks you can do. And just noticing, of course, this is equal to 2 lots of A plus 2 lots of B, if you like. Good stuff. Your turn to have a look now at some figures here, and I'll just hide those answers there so you can have a go. Trying to do it in a shorter way rather than adding up number after number. See if you can group them together, whether you've got 2 of one and 2 of another, or something like that. Okay, pause the presentation, have a go. I'll show you the answers now. So there are the answers up to the end of question 4. I think we've got 10 questions here, so it shouldn't take you as a budding young mathematician long to get through them. Let's have a look at some variations here. So here's a different looking couple of figures. We've got one that is just an ordinary quadrilateral, no special things, so you're going to have to find the total distance right around the outside by adding them all up. And the important thing here is you've got to keep the units the same. Okay, see that one and that one? We might change to our basic unit of metres. So there are more, the metres are smaller, so there are more metres than kilometres. It's going to be times then. Going to a smaller, you're going to make more smallers out of those biggers. Oh, big ones, sorry about that. And then 800 and 700. So you've got to convert to a common unit. And quite often, that's our base unit, which would be metres here for distance. A rectangle, we can say there's going to be 2 lots of 4 and 2 lots of 5. Or add up 4 and 5 and double it. But just before we do that, have a look in here. This is a little bit sneaky. 4 centimetres, but these are millimetres. So look in here, you've got to change 4 centimetres to millimetres. So we'll work with millimetres, so we've got nice whole numbers. We won't change the 5 millimetres to centimetres because we only have 0.5 centimetres. Do you agree with that? Check that. All right, so what's the common unit now? So I'm going to give you some problems where you've got to watch the units involved. We don't just jump in and start adding stuff up that are different amounts. So here we've got centimetres and millimetres, and centimetres and millimetres. So you're going to have to change them using the work from the first presentation, changing units of length. Okay, pause it and have a go. And when you've done a few in question 5, toggle forward and make sure you're getting them right. Okay, don't perpetuate an error. All right, so try question 6 then, and I'll just scroll through these, and then you can have a look at the answers. Okay, then question 7, 8, and 9. Okay, interesting watch face here, so you might be wanting to do work in a jeweller's shop and put diamonds or something around the outside. You've got to know the total length or perimeter of the face there. Okay, so think about that. Just watch the units. Watch the units here. Okay, there's some tricks going on. Okay, and if you're not sure, you could draw a little picture to help you work these things out. All right, last one now I think is number 10. We've got our stained glass window back. Okay, and they're talking about the perimeter of all the little pieces inside, because they could be lined with lead glass window, or tinting of windows and things like that have surrounds around each individual piece. So you might want to work out the glue strips and stuff required to join those pieces together. All right, hope you're enjoying this. I hope you can see this is maths in a practical sense now, and you can get excited about being useful in your calculations. Let's have a look at the answers. Okay, so there's the other set of questions now. So I hope you got a few right, and you might have to ask your classmates and teacher for some help to make sure of the ones that didn't come out quite close enough, didn't come out to the right answer. Okay, well, we're going to have several presentations on measurement because it's an important area of maths. But for now, it's cheers from me.